Again, we talked about picking clever values of x. So what I would do is choose 0, 1, 4, and 9, because they're perfect squares. You can't choose negatives, because you can't put negatives underneath square roots. And choosing values in between 0 and 1, I would kind of need a calculator to do, although I could estimate. But 0, 1, 4, and 9, I can evaluate really easily. So the square root of 0 is 0, 1, 2, and 3. Now, you can go right ahead and plot those. 0, 1, 1, 4, 2, and 9, 3. Your graph should look like that. That's the standard square root graph. Without any shifting, any sort of transformations, that's what the standard square root graph looks like. It starts here because you can't plug in anything negative. Now, for this one, it says to use your calculator. Now, you could do that. So let's take a look at our calculator. And I turned on just x plus 3 minus 2, so that's what I'll be looking at. And I'm going to go ahead and hit the graph, and that's what it looks like. But sometimes I'm just going to remind you, there's sort of like a little bonus. This goes from -6 to 0, this window. And then from 0 to positive 10 on the x-axis. I can duplicate this window so that I'm looking, so I'm kind of comparing apples to apples. So I can look at my calculator and I can match it up against my graph to make sure everything's good. So you just go to your window settings and you say, okay, well, x min is -6 on my graph and x max is 10. Y min is -6 and the graph goes up to +6 on y. So now I'm looking at a graph that is the same dimensions as the one on my paper. So it's kind of easier to spot mistakes and make sure you get it right. Okay? So that's what your graph should look like. Now you can use that calculator, or you can go ahead and go to the table and start the table at -10 like it could ask me to. And what that wants you to see is all those errors. So who can tell me why that calculator is producing errors? Why is it producing errors? Granny?
You can't have a negative size.
Right. In other words, if you plug a -10 into x plus 3, that's going to give you -10 plus 3 is -7. The square root of -7 is undefined. And it's going to continue that way all the way up until -3. Because -3 plus 3 is 0, and you can take the square root of 0. That's why you start getting values at -3. So that's what they wanted to see you do there. So you can use this table all the way from -3 and plot them all the way to where it goes, which is up to 9. And you can do that. And every once in a while you'll find an integer to make your life easier. But we just stopped with transformations in Unit 7, right? We're going to assess on Monday on that. And we said that inside parentheses, if you're adding or subtracting a number, something happens. What type of shift happens when I add numbers and subtract them inside parentheses? Horizontal shift. Very good. You have to think about square roots. It's not really parentheses. It's actually grouping symbols. And square roots count as grouping symbols. So the same thing's going to happen inside a square root. If you add 3, it's going to shift it to the left 3. And when you're outside of that grouping symbols, outside of the square root, that's your vertical. It's going to go down 2. So really, all you need to do is point for point, take 0, 0, move it to the left 3 and down 2. And there it is. I'm going to use a different color. Take this point 1, 1, go to the left 3 and down 2. 4, 2, go to the left 3 and down 2. And then 9 to the left 3 and down 2. So this has actually been shifted to the left 3 and down 2. It's a heck of a lot easier than plugging into the calculator, no? Yeah. And that's the whole idea of this, so that you can go on to advanced mathematics and not have to fumble around with calculators. You can be more efficient about graphing and thinking about and analyzing graphs. That's really what this is about. There's no real practical application other than preparing you and helping you in advanced math. Okay? Stuff like that. Okay, so now let's just state the domain and range of each. So f of x is the square root of x. That's the red function up there. So our domain is going to start at 0 for x and go to infinity. So we're going left to right. So x is 0 and it goes to positive infinity. Now remember, the square root of 0 is okay, so do you see how I put it in a square bracket to say include 0, please? Same thing for y. We're going to go from 0 to positive infinity, because this graph, it is gradually increasing, getting higher. It may take a long time, but it's going to get up to positive infinity. So the range is the y values, so x, y, and that's going to go from 0 to positive infinity also. Now, the domain for this one, we can look right at the graph. The x values are going to start at -3, and they're going to go to positive infinity. And the y values are going to start at -2, and they're going to go to positive infinity. Is that okay? Any questions so far? Feeling good? Now, all right, take a second and do this one in your calculator. And I'll give you 2 minutes just to throw that in your calculator and look at it. And we'll get started talking about it in a sec. Now just be careful, because you're probably still in that other window if you reset your window settings. So here I just turned on the square root. Now, I'm going to go look at the graph, but I can only see one side of it. If you go to Zoom 6, which is your standard 10 by 10, there's 2 sides to this graph. Okay? So I'm going to put this on my screen. Zoom 6 always gets you back to 10 by 10. Now, that's what the graph should look like. And the reason why it looks like a square root graph, kind of, but two-sided, is because it's a quadratic. And here's what I mean. If I go ahead and I set up, remember how to find the domains of radicals algebraically. What you do is you take the inside and you set it greater than or equal to 0. Okay, that's what it means by set up a quadratic inequality that gives a domain. Now you're going to solve this as if it were an equation, because you need to find the zeros. So I'm finding the zeros, or the x-intercepts. So this is going to factor into x plus 4 times x minus 2, excuse me, x plus 6 times x minus 2. And that's going to give me x-intercepts of -6 and +2. So does that look kind of like it has a relationship with the graph, the square root of that parabola? It does. So let's visualize this parabola now. This parabola opens up because it's got a positive a value. So that means it's going to look something like this. So all the values on this parabola are going into the square root. Between -6 and 2, the values are negative. They don't appear. That's because you can't take the square roots of negative numbers. However, if you look to the left and on 6, -6, these are all positive values. That's why you can take the square root of them. Does that make sense? And as the parabola goes out to the left, it's taking the square root of a bigger and a bigger y value. Same to the right. So that's how you find the domains of radicals. You take the inside and we just analyze the parabola. But it could be a linear. In other words, you could have the square root of 2x minus 3. You would do the same thing. You would say 2x minus 3 is greater than or equal to 0. Add the 3. 2x is greater than or equal to 3. Divide by 2. There's your domain. X is bigger than 3/2 or equal to. So if you recall that from way back in the beginning of the school year, that's what we were doing. That's why we're reviewing it. So if you're asked to find the domain of a radical with a quadratic inside, visualize that parabola. If it's a linear function, again, just set up the inequality and solve it, just like you've been doing for years. And you're all set to go. Any questions? Are we okay? All right, so I'm going to let you get started on that problem set. I'll walk around and give you a hand.